Hello everyone and welcome back to my channel. My name is still Emeka, and in this video I will show you how I implemented a workflow orchestration using Apache Airflow. This project is focused on automating and managing data workflows, ensuring that tasks are executed in the right order and at the right time. I'm only going to be chaining this task sequentially using Airflow. Like I said before, this is relatively a new account, and I'll plead with you to kindly subscribe. I know the videos are not perfect, maybe the editing is not perfect, maybe the explanation as well is not that perfect, but at least with your subscription and also likes and all that will give me encouragement to make better videos in the future. So please kindly like and subscribe to this channel. Thank you. So this video will focus on how we use Airflow to orchestrate the entire data pipeline. So basically, what are we going to learn here today? We are going to learn some few things, and we are starting with learning how to use Airflow DAGs to automate workflows. Also, we are going to learn how to schedule and manage dependencies between the tasks in this particular Airflow project. And also, we're going to learn how to create external tables in BigQuery from our Airflow DAGs. And we're also going to learn how we can use several Airflow operators, including bash operators, BigQuery insert job operator, and DBT task group. And also, finally, we are going to learn how to switch between development and production environments in the pipeline. So now we are going to chain these various tasks sequentially, project. And also, we also have the script to generate the raw data. So the first and the fourth part we already have. So all we're trying to do is to chain these tasks sequentially using Airflow. That is what this project is all about. The first task we have to run first and generate the raw data and load it in Google Cloud Storage. Then after that, the next task we run, which is about BigQuery, and then after that, the next task we run, which is about performing some generic tests on the source data, and the final task we run, which is about a DBT transformation. So if any task here fails, that means the following task is not going to run. That is what this sequential chaining is all about. So if the generic test fails, then the transformation is not going to run, because especially in development where we're going to be having this, we don't want a situation whereby the test phase and then we're having a bad data in maybe in our production environment and all that. So the essence of this whole thing is that if the test phase, we don't want the transformation to run. So if it fails, then we have to take care of whatever is failing and then rerun the whole project again. So all these things are going to be dependent on each other. So also in this project, we are going to be using Cosmos to orchestrate DBT runs, and in this project, we are going to be using Cosmos to orchestrate DBT runs within Apache Airflow instead of running DBT commands manually via bash operators. And before we begin properly, we need to have Docker installed in our system. We also need to have Astro CLI installed, and we also need to have a Google Cloud platform account, which I already have Docker and Astro CLI installed within my system as well. So now let's start with the project. As you can see, I already have my VS Code open, and I already opened the project folder, which is Airflow DBT GCP. And like I said, I've already installed Docker and Astro CLI, so you can just confirm if they are already existing by typing Docker version. Here, as you can see, I have a Docker version 27.4.0 already in my system. And let's also So let's also confirm Astro to see if Astro CLI is already installed. So you can just type Astro version. Here you can see I already have Astro CLI version 1.32.1 installed. So let's begin properly with the project. So now we have to initialize an empty Astro project by typing Astro dev init. So this will create a new project structure for us. As you can see here, new project structure has been created, which contain the DAGs folder, include plugins, tests, and also the Docker file and the requirement.txt file. So this is what we are going to be modifying today, and also adding our different tasks within a DAGs file that we are going to create. So for now, we already have some example DAG with this initialization, which comes with it. This we can actually view this in our UI by running Astro dev start. Now I got this error because I didn't open a Docker desktop initially, and that I have done now. So let's run it again. Astro dev start. So it's building now. So as you can see, it has finished building and the project is now running, and we can view it the Airflow UI via this Airflow web server, this particular address. So let's copy this and go to our browser. So here in our browser, we just opened the Airflow web server. So the username is admin by default, and the password is admin also by default. So let's sign in. So as you can see, this is our first project, which is the example project that comes with the initialization. We don't need all this, but as you can see the graph, but this is not what we need. We are going to now build our own project, create our own DAG file, and also add our different tasks in our DAG file as well. So let's do this. So now let's delete this example DAG file, which came with the initialization. We don't need it, so delete, move to recycle bin, and then let's create our new DAG file that we are going to be using to sequentially chain these tasks. So create a new file. Let's call it healthcare dag.py. So the first thing we are going to do is to import DAG. We are going to do this by using this, that is from Airflow.decorators. We are going to import a DAG decorator, and basically what the DAG decorator does is to define the DAG and specify the metadata such as the schedule, start date, the tags, and also the catch-up. That is what we are going to use the DAG decorator for. And also we are going to need date time from the pendulum, and date time will basically be for scheduling. So we are going to also need this. So now that we've imported the DAG, we can now use the DAG decorator by saying @DAG. You can see automatically we have some arguments within the DAG decorator. Just press tab and we'll have them automatically filled. So here we have schedule interval equal to daily, start date equal to date time, maybe a time in the past. But let's see, let's properly format this. We also need a catch up. Catch up is equal to false. We need tag equal to healthcare. And what else do we need? We can add a description, which is equal to, we want to use the schedule argument instead, and we want to use null because we don't want to schedule this. So we use schedule argument is equal to none. Start date, you can say 1st of January 2025, or let's use 2024. Catch up is equal to false. Healthcare, tags equal to healthcare, description, healthcare data pipeline. So now we have set up, we have properly configured our DAG. The next thing to do is to prepare our first task, and our first task is our data generation task. And we already have a Python script which basically generates our data in different formats and then load the data in our Google Cloud Storage. So that Python script is what we are going to include in this particular task as our task 1. So where do we add this script within our project structure? We go to include. Let's create a folder, a subfolder inside include. I will name it raw data generation. That is the name of the folder inside include, and then within this folder we can now add our Python script. So have this Python script here. That is what we are going to use as our first task, but we are not done yet. We are going to create our service account. Service account is the authentication method with which you can connect to Google Cloud Platform. So within this include as well, you can create another subfolder, name it GCP. So inside GCP, we are going to paste our service account. So come down here and then we'll paste our service account. So this is our service account within GCP, and we have our raw data, healthcare data within our raw data generation. So these two things are needed for our next task. So now that we have added these needed files, we have to indicate the path to this file within this our DAG folder. Can come down here and paste this path to our data script. Inside this Airflow container, we have this include folder, which is inside the Airflow container. Within the include folder, we have a subfolder named raw data generation, which is this, and within that subfolder, we have this healthcare data.py, which is the Python script to generate our raw data. So we have to add this path to our DAG before creating the first task. And in creating the first task, we have to first create a function. In this case, we can name our function dbt healthcare pipeline. So within this function now, we are creating our first task. Our first task here is generate data using a bash operator. That's what you're going to use to run this Python script. So the task ID is generate data, and the bash command you're going to use every other time we run the Python script is Python and then the name of the Python script.py. But in this case, we're already given the path to the Python script. So we say Python and then the Python path to the data script. So this will basically run the data generation script as our first task. So we have to call this function at the end, call the function, and also we have to call this task. So have a generate data task. This is our first task, but as you can see, we haven't imported the bash operator, so we have to also import the bash operator. So here we say from airflow.operators.bash import bash operator. So that gives us this. So in this case now we have to restart our Airflow by saying astro dev restart. But first we have to save our changes and then we restart our Airflow. So our Airflow has restarted, and we can view it within Airflow UI to see what we have if our new DAG task is already present in our Airflow UI. So as you can see, we have a project, the DBT healthcare pipeline. Let's go into it and click on graphs. You can see we have the generate data batch operator here. We can run it manually to see if we have any error or if everything runs very well. We have an error. Now we need to make some changes within the Docker file as well, and in this case we have to create a virtual environment and activate the virtual environment and install the needed libraries within the virtual environment. For instance, we need to install dbt, BigQuery, and also these pandas, Faker, Pyro, and NumPy that are needed for the raw data generation. We need to install this as well within the virtual environment. And then this part, this run echo, basically creates a script that automatically activates the virtual environment when running dbt related tasks. That's what this particular run echo does. And then the last part basically ensures that the activation script is executed for Airflow to use when needed. So that's what this particular part does. So these are all needed for this project. I had to do everything here at once because without this, we won't be able to actually run the first task, which is needed. So I had to do everything here. So now that we have done this, let's save it and then restart our Airflow. Now Airflow has restarted, so let's view the changes in UI and see if we can trigger a run to see if our raw data will be loaded into our Google Cloud Storage as well. If that happens, that means we have successfully completed the first task within the orchestration. So we are within Airflow UI. So let's trigger a run. Let's view the graph. So as you can see, it's green, it's running. So it has finished running, and then you can see it shows success. That means it ran successfully. So let's view the outcome in the Google Cloud Storage to see if our bucket we are loaded with the raw data. Let's restart, reload. So as you can see, the time now is 15:25. So and here we have that is at 324, which is correct. So files were created at this time as expected. These are the raw data within the Google Cloud Storage. So this simply means that we have successfully completed the first task. Now let's go to the second task. But before we go to the second task, let's add some connections about Google Cloud within our Airflow UI. So let's do that. So within Airflow UI, you click on admin, click on connection, click on the plus sign to add new connection. Here, connection ID, you can say Google Cloud Platform GCP. Here, look for Google Cloud. Under connection type, click on Google Cloud. Then the project ID, we get the project ID. So to get the project ID, we go to Google Cloud and then go to our project, and then this is the ID. We'll copy it and then go back, paste it here. This is our project ID. Sorry, the key file part is the path to the service account that we created within the GCP folder earlier. So basically we just get the path and then paste it within the key file part here. So that will be this. So these are the credentials that are needed at the moment. As you can see, we have GCP, we have the Google Cloud given, the project ID, and then the key file part. Well, we can't test this here. For us to be able to test this, we have to go back and modify or enable it within our development environment. So go to VS Code. So, but for now, let's save this connection. So now we are done with the first task, and then we are going into the second task, which is basically creating external tables in BigQuery. Now, why is this necessary? External tables allow us to query data directly from the Google Cloud and storage without first importing it into BigQuery. This will help reduce the storage cost. Also, BigQuery can handle BigQuery external table can handle CSV, JSON, and package file, which are the files we have created here, and making it easier to manage various data sources. Then the external tables serve as the source layer for dbt transformation, ensuring that all the raw data is accessible. So let's go to the second task, which is the BigQuery external tables. I'm back to our VS Code, and here we need to add our second task. And this second task will basically help us create the external tables like we said earlier. And to do this, we need to import an operator, and the operator is called BigQuery insert job operator. What this operator does is it helps us run SQL within our DAG file. So we need to import this operator. First of all, I have to add it here. So from airflow.providers.google.cloud.operator.bigquery, import BigQuery insert job object, which basically helps us run SQL queries. Now, after this, we have to, within our function, define our second task. But before then, we have to know the query that we are going to be running. And that query will create external table. And how do we do that? We don't want to create that query within the DAG file. We want to create that query somewhere else and then import it down here to make use of it. So what do? Within include, and within the raw data, we are going to create a new file, and that file will be called the file will be called createexternaltables.sql. So here within the raw data, create a new file, and we call it createexternaltables.sql. So this file is going to hold the logic that is going to create that external table. So let me copy the logic and paste here. So this is the logic. The first one is create or replace external table within this project, and then within this dev healthcare data schema, and the name of the table, external table, is going to be patients data external. Same thing, we have 3 external tables. Same thing will be done for these 3, and these 3 tables have different file formats. The first one is a CSV, the second one is JSON, and the third one is a package. And this URIs is the URL of the data we just created, which is in our Google Cloud Storage. So this is like a pointer. You are telling the system to go into this particular URL and fetch this data. But you are not uploading this data to BigQuery. You are just pointing it or creating it as a pointer to the raw data in Google Cloud Storage. So that is what this external table does. So we have created this now. So this is the URL. This is the URL pointing to the source data within the Google Cloud Storage. And basically what we are saying is the table is external, meaning that the data remains in Google Cloud Storage and is not physically loaded into BigQuery storage. So now let's create the DAG file that is going to run this particular SQL command and then create the external table. So that will be our second task. But first of all, we need to bring in this file and then open it within this DAG file and then run the SQL command. So first we have to get the path to the SQL script, and then so we'll get the path to this SQL script, and also we are going to get the connection ID which we just created within Airflow UI. So post both of them here. So have the path to the SQL script, which is this present in this same folder. This is what we just created, and then the Google Cloud Platform Connection ID. This is going to be based on the variables that we are setting within the Airflow UI. So we are saying that whatever is the connection ID in Airflow UI, make use of it in this particular authentication. So here we are going to use that Airflow UI variables. So whatever it is, by default, we'll give Google Cloud Platform, but what if in future we decide to change it? If you change it, we don't need to come down here and manually modify it. It will infer it automatically. So we are using this as well. And now we are going to open the SQL script on read mode only, so we can be able to run the queries that are contained in it. So we say with open, now path to SQL script on read mode only, and then this is the variable that's going to read it. So create external tables SQL. So now we can now create the second task for this DAG. So this is the second task for this DAG. So create external table, BigQuery inside job operator. So this job operator will help us run the query. These are the parameters that are actually some of the parameters that are actually contained within the BigQuery inside a job operator. So have task ID, which is a create external table, and this is what is going to show up in Airflow UI. Then this is the configuration. We accept some parameters as well. The query, and within the query, what are we querying? We are querying the create external table SQL, and then SQL legacy SQL is equal to false. So the location is which matches our BigQuery dataset location. In my case, it's Europe West 3. And then the connection is this GCP connection ID variable we just created here. So this will help us with the second query, and then now we chain it. So now we have generate data. After generate data, the next thing should be create external table. So we'll save, and then we'll start our Airflow. So our Airflow has restarted. Now we are within Airflow UI. Let's view if the task we just added will show up here. So click on this, click on our project, and then click on graph. So as you can see, we have generate data, which was our first task, and now we have create external table, which is our second task. So let's run this manually and see if everything is successful. So as you can see, generate data ran successfully, which is the first task, and now the second task, create external tables, also ran successfully. Let's view this in BigQuery to see if these external tables, since they ran successfully, let's go into BigQuery to view if these tables were created. So as you can see, within the dev dataset or database in this case, we have claim data external, arrow data external, and patient data external all created. You can see the details when they were created, which is today. So the second task ran successfully. So let's go to the next task, which is the third task. So for the third task, we are to run some raw data generic task using DBT testing. And why is this necessary? Basically, it helps validate that the raw data meet the expected requirements or formats before we perform our transformation. Also, if issues are found in source data, in source tables, they can be fixed before transformation occurs. And also, this setup helps us. This setup enables Airflow to trigger DBT tests automatically within the DAG workflow. So since external tables were created in task 2, this step confirms they are accessible and correctly structured. Now, at this point, we are going to bring in our DBT project, which we had already designed in the past, which was already functional. We're going to bring it into this particular project. And where do we add it? We are going to add it in include. In some cases, some people add the DBT project within the DAGs folder, but I think DAGs folder is supposed to be left for DAGs only. So that's why I'm adding it in include folder. So within include, I'm going to create a folder under subfolder named, and then within that subfolder, I'm going to add my DBT project. So as you can see, we have healthcare DBT query data pipeline within the DBT project. So inside this DBT project, we have the models. This is where we develop the models, the SQL models for the transformation. This we discussed in our previous videos, and the schemas for the test and the sources to define our sources. In this case, our external tables from BigQuery. This is what we have. We have 3 sources. First one is patient data external, and then we'll perform some generic tests here, like in the patient ID. The test we're performing here is it must be unique and not null, which basically means that it shouldn't be empty. And then in the in the first name column, we are saying that it shouldn't be empty. The last name shouldn't be empty, and the age shouldn't be empty. Gender shouldn't be empty. These are just some generic tests that we are performing for the source data. And then the same thing is done for EHRO data external, which is also another source data. and also claim data external, which is the other source data. So here we are performing saying that claim ID, which in this case is the primary key, should be unique and also not empty. And some other tests are performed in other columns. So these are the generic tests that have been performed for the source data, which are defined here. And the schema.yml file contains all the tests that will be done on the transformed tables. But that is not what we are discussing here. So let's go to the next part, which is developing the third task within our DAG, and that is our raw data generic test. So also here we have here we'll be talking about the DBT project, which is also contained within the DBT project folder. And the DBT project basically defines the DBT project and configurations. And here we have the name, in this case, which is healthcare DBT BigQuery data pipeline. The profile, basically the name of the profile.yml file, which we have here. Healthcare DBT BigQuery data pipeline, that is the profile. So that is this one. And then the model part is models, because it's within the same directory. So saying that the materialize should be view. Instead of creating tables, you are creating views in this case. And then the profile.yml file is also here. Here we define for the development environment and the production environment. For development environment, we have the dataset name as dev, starting with dev. Dataset in this case is basically database, starting with dev. And the key file here is the path to the service account, which we created initially within the GCP folder here, which is this. So this contains the service account, which contains all the authentication credentials. Location is Europe West, and method is service account. This is our project name within the Google Cloud Platform, which is the same as this, and type is BigQuery. Type here is the adapter we are using, which is BigQuery. So by default, the target is dev, except otherwise, maybe otherwise specified that it's going to be prod. So here we have also defined for prod. The data set for prod is prod healthcare data, or basically the database. So whenever we are accessing the prod, we'll be accessing the production data, the source data as well. And then the transform data that's from production will also be placed within this production healthcare data set. The same thing is also applicable to the development healthcare dataset. So I think that is all for the DBT. Now let's go to our DAG. Now we need to configure Cosmos to work with DBT, and in this case we need to configure Cosmos so that Airflow knows which DBT profile and target name to use. And to do this, we have to create a new file, even though I've already created it here, which is this. So you create this file, and the file should be named cosmos config.py in this case, and inside our it should be within our DBT project, which is this, because it's within our DBT project. So this is where we are supposed to create this cosmos configuration file. So what does it contain? We have to import a profile configuration and a project configuration. Profile configuration helps us configure our profile.yml file, or basically points to the part where the profile.yml file is, and also help to define which environment we are targeting, as defined also in our profile.yml file. And also we have to import the project configuration, which basically points to where we have our DBT, this particular DBT project file. So we have to do two things within the Cosmos configuration: configure the profile.yml file and configure points to where dbt project.yml file is. So that is what we are supposed to do within cosmos.config. So as you can see here, the profile name is healthcare dbt BigQuery data pipeline, which is the name of the profile.yml file, and the target environment in this case is dev, which is the target name, and the profile YAML file path is this. So as you can see, we have it in include dbt healthcare within a healthcare dbt project, which is this. So you can see the profile.yml file, and then the dbt project configuration basically points us to where we have this dbt project .yaml file. That is what this cosmos.config is supposed to do. Now let's define our new task in the DAG to run a dbt source test by adding the task for this. So we say dbt test raw. So we are using, in this case, batch operator to run the command, and in this batch operator, the task ID identify the dbt testing task in the DAG, and here the source batch command activates the dbt virtual environment and runs source level test, and CWD basically in this case ensures that dbt runs from the correct directory where dbt project.yaml file is located. These are the parameters we give for us to run this dbt test. So let's call the test. So after this, we are supposed to restart our Airflow, but I don't want to do that now. I want to continue to the next task. At the end of the tutorial, we are going to run a restart our Airflow and then see if all the tasks are running successfully. Now, the fourth task basically run dbt transformation only if dbt test in the previous task passes. So why is this necessary? Basically, this ensures that only valid data is transformed. So if there's an error within the test that was performed, we don't need to go further. And also it improves our DAG readability if we run dbt transformation only when the initial dbt test passes. And to do this, we are going to import some modules. We are going to need the dbt task group from the dbt task, and we are going to need to import the dbt project config and the dbt configuration that we created in the cosmos.config file. We need to import that here as well, and we are also going to, let me just import them. So here you can see from cosmos.airflow.task group import dbt task group. So dbt task group helps in organizing all our dbt related tasks inside a structured task group. The dbt task group is a pre-built task group in Airflow, which is provided by the Astronomer providers package. And the second one here is the load mode from cosmos.constant. And what this load mode and the render config does is basically they help find how dbt commands are executed dynamically inside the Airflow. So now let's create the fourth task. So dbt task group accepts some parameters. The group ID, in this case we have a transform, and the group ID basically creates a task group in Airflow for all dbt related tasks. So within this transform, we are going to have all the transformed models. And then we have the second one, which is the project config, which specify the path and settings for the dbt project from a cosmos.config file, which we created earlier on. And the profile config, in this case, specifies the path to our profile.yaml file, and also the target name, which is the target environment, as specified in the profile.yaml file as well. And the render config basically define how dbt commands should be executed dynamically. And this path basically gives us the path to our model, and the dbt executable path ensures dbt run from a correct virtual environment inside the Airflow container. So as you can see here, it activates the virtual environment and then runs within the right Airflow container. So now we have created the fourth task. Let's call it here and save. So let's restart our Airflow. So our Airflow has restarted, and Airflow has restarted. So let's test our task locally first before checking the UI. The first task we have to test is the dbt test raw. So let's see if this is working locally, and let's also check if the transformation is working locally before we can go to UI to confirm this. So let's first of all open a shell inside the running Airflow container. So by saying astro f bash. So we are now inside the container. Let's navigate to where we have our DBT project. So we are within the DBT project now. So let's run DBT test. We are testing the sources, in this case the source data. So let's see what happens. So you can see the tests are passing, so completed successfully. We'll have pass equal to 14, warning 0, error 0, skip 0, total 14. So let's also run the transformation to see if that worked well as well. So we'll say dbt run, and we'll give the path to the models, in this case which is models. So it's running successfully, created a table, so completed successfully, pass 5, total 5. So locally both tasks, dbt test and transformation task, they both ran successfully. But before going to the UI, I need to touch on one thing: how we can switch between the development and a production environment here without modifying the DAG file all the time. So how do we do this? That is what we are going to touch next. So here we defined the target environment in our cosmos.configuration file, which is this. This is where we define the target name is dev, and this dev is also related to the target that was defined in the profile.yml file here. So you can see it's either dev or prod. So this cosmos.config is taking the environment target from this the profile.yml file. So in this case, by default we set it to development. We can easily change it to production as well, but if you do that, that means you have to go back to the DAG file to also make some changes for this to happen. But we don't want to be doing that all the time. We just want to only switch within the cosmos.config file if we want to switch between development and production environment in case of deployment. So what do we do in this case? Let's go back to the healthcare. We have to import the target environment into our DAG file. We already have a dbt imported here, dbt config imported here. So just target environment equals to dbt config.target name. So we already have a dbt config imported here, which is this. So target environment is equal to dbt config.target name. Now also we need to modify the SQL file dynamically before execution. So instead of using hard-coded dev reference, we modify them dynamically before executing the SQL in Airflow. So that means this with open on read mode only. We can also now say, after opening the SQL file, we want you to replace anything that is called dev healthcare data, because by default that is what we have here. So we don't want to create another SQL file for production. We just want to use the same development SQL file. So we are saying replace, replace this dev healthcare data. So replace dev healthcare data with the target environment. Now target environment can be dev, it can be prod. So if it's prod, you are replacing it with prod healthcare data. And then also within the source URL, let's go back. You can see within this source URL we have the bucket where this raw data is. We have development here, and we are also saying in case we are switching to production, also replace the development with prod. So that's what we have here as well. So you're also replacing the dev with target environment. Target environment can be dev, it can be prod. So if it's prod, so you are replacing that dev with prod. So it simply means that if you are deploying to production, it will take its data, its raw data from the production bucket. And if you are in development environment, you should take its raw data from the development bucket. So we have adjusted this dynamically. So now we don't need to come down here to change it each time we are switching to production. Now another thing is, I want a situation where if we are working on development environment, I want to run this test, but if we are working in production environment, I don't want to run this test, because that is the essence of running the test. The essence of running the test is in development. If all the tests pass in development, I don't want to repeat the same thing in production environment. Production simply means that we are okay with the test that we have conducted and it's okay, and we want to progress further. So in production environment, I don't want to include this test, so I have to modify this as well. So in this case, if target environment is dev, I want you to run this, and then I want you to generate data, create a standard table, and run the test. Otherwise, I want you to only generate the data and create a standard table. Don't run the test. Otherwise here means if it's production, because I only have to either dev or production. So now I also have to modify this part. So if target environment is equal to dev, I want you to run the test before running the transformation. Otherwise, I want you to create a standard table and go straight to transformation. You don't have to run the test. So otherwise here means if it's in production environment, after generating the data, creating a standard table, you go straight to transformation. You don't have to run the test, because I don't need to run the test in production environment. So now we are basically done. So let's save, and then let's restart our Airflow. Let me exit the container first, and then restart our Airflow. Sorry, I think I made a mistake. I'm supposed to remove this final part, since I've now given it some conditions. So this is the right one, and let me restart my Airflow. So Airflow is starting up. So our Airflow has started. So let's view it in UI. So let's refresh, or let's just run. Something went wrong. So we got this error in Airflow UI. It says module not found error. No module named Cosmos. So we made a mistake. We are supposed to include that in our requirements.txt file. So let's just do that. So let's open up our requirement.txt file and then paste this there. Control save. So now we have Astronomer Cosmos, this version, and we also have Apache Airflow provider Google. So this is inside our requirement.txt file, and we'll save it and then restart our Airflow. This time it should be fine. So our Airflow has started again. So let's view our Airflow UI to see if the error has been corrected. So reload. Now we have this, and let's go into it. So our Airflow has finished running and restarted, and now we can view our Airflow UI to see if the error has been corrected. As you can see, we don't have the error anymore. So let's go into the project, and let's manually run this project. Let's view the graph. So as you can see the graph, we have the task basically chained the way we want, and the dependencies are showing. This is in development environment. So you can see we have the test, the dbt test raw within the graph. Let me zoom in. We have generate data, create a standard table. This one has finished running successfully, and now we are running a dbt test raw. This is still running. It has finished running successfully. We can view the log, so you can see completed successfully. Here we have all the tests pass, so they all pass successfully. That is for the third task. Let's go back to the graph. Now, within the transformed task, or transformation task, we have several tasks here. We have the run for the health anomalies, and we have tests for health anomalies as well. After the run, you test it. The same goes for the chronic condition summary. After run, you test. So they are all clubbed into the transform task ID, which we created. So this is still running at the moment. We don't know what the outcome will be. So the transformation task is now running. So let's wait. The run is finished for this. So let's see the log. So completed successfully, merged 1500 rows. Let's go back to the graph. So they have all completed successfully within the development environment. So let's go to BigQuery and see if the tables were created and we actually have data in them. So this is our BigQuery. You can see in development environment we have all the tables created. We have chronic condition summary. Let's preview. You can see the table. Then we'll have high claim patient, we have patient data external, we have health anomalies. Let's see health anomalies. Preview. So as you can see, BC date, heart rate, blood pressure, temperature, anomaly flag, high heart rate, and all that. So this worked within the dev, but the prod, do we have anything? No. Prod is empty because we haven't switched to the production environment. So let's try and switch to the production environment and see if the production environment will be populated. But first, let's see details. Here within the development environment, we have 4,550 records for this particular health anomalies. So let's go back to our VS Code, and then let's go to cosmos.config file, and then let me comment development and switch to production. Save. So let me restart my Airflow. So our Airflow has restarted. So let's go back to our Airflow UI. So in our Airflow UI, let's rerun. Let's run our project. Let's view the graph. So as you can see in the graph now, we have the test eliminated because we are now running within the production environment. So you see generate data, create external table, and then go straight to the transformation. There's no need for the test that is in between the create external table and the transformation during the development. Now that is eliminated because we don't need that in production. We already confirmed that everything is fine within the development environment, so we don't need to repeat that again in the production environment. So in this case, we only have generate data, create external tables, and transformation task within the production environment. So once this is done, you're going to confirm from BigQuery if the production environment is actually loaded with the tables and also the data. You can see for each model, we have run and test, run and test, run and test, because we use the DBT task group and this task group basically run each time DBT run and DBT test. So for each model that you want it to run, so that is what happened here. But for the other tests that we created using the batch operator, that has been eliminated. That is for testing the raw data. We don't need to test the raw data anymore because we have already done that in development. So in production, that has been eliminated. So now everything has finished running successfully. Let's go to BigQuery and then view it. Reload. So you can see now in production, this is dev. You can see in production we have our data. Let's see health anomalies, details. In production we have just 1,539 health anomalies. So that brings us to the end of this project. And what did we do? We created an Airflow orchestration project, which basically changed this task sequentially. Task 1, 2, 3, and 4 were changed sequentially, and what happened? The first task was able to load them within our Google Cloud Storage, which is our data lake. The second task was able to create external tables in BigQuery, and then the third task was able to create some generic tests on the source data, and then the fourth task was able to perform the actual transformations and create the needed tables, the needed views in BigQuery. So this is what we have done with using Airflow. Like I said before, this is relatively a new account, and I'll plead with you to kindly subscribe. I know the videos are not perfect. Maybe the editing is not perfect. Maybe the explanation as well is not that perfect. But at least with your subscription and also likes and all that will give me encouragement to make better videos in the future. So please kindly like and subscribe to this channel. Thank you.